Hello everyone, welcome back to OnPrep, and today we are discussing about one of the important topic which is widely asked in the system design interview, which is ticketing system. Also, BookMyShow, which is used across India for booking the movie tickets. Similarly, TicketMaster is being used in other countries. Though today we are gonna focus on the movie ticket booking system, but this concept can be applied for any system where the inventory is limited. I mean, it could be a airline reservations generally in the peak seasons for festivals during Christmas, New Year, where there's a lot of concurrency, where a lot of people are booking the tickets in airlines. Similarly, in weekends, holidays, festivals, many people are trying to book the movie ticket at the same time. So we wanted to focus on the concurrency issue for this particular system, and more specifically, interview would be looking for you how you would handle the concurrency happens during multiple people are trying to book the same ticket. And as we mentioned in one of the previous videos, we will be going with the step-by-step approach, and I recommend 7-step approach for system design interview. If you have not watched my previous video, I would highly recommend you to first watch the video, which will help you to understand the format of the system design interview. So let's start with step 1, which is functional requirement. Functional requirement is the core functionalities of the system which it must support. For example, we wanted to build the system which has a feature for searching the movie ticket. As I have mentioned earlier, this can be extended to any event similar to movie, but we wanted to focus on the movie as part of this requirement. Search movie by its name, category or language, and many other parameters. View movie details and book tickets. So these are the 3 core features which we are trying to build. And as we go in detail, we will see what are the bottlenecks are there when there are thousands of people trying to search the movie by a search criteria, and other part of the system are like when many people are trying to book the tickets at the same time. That has another challenge. So these 2 sub problems of these topics are totally different, and we wanted to focus on the core functionality, core requirement of the system, and show our technical skills how we can scale our system based on this core functionality. Next is the non-functional requirement. While we start the discussion about the non-functional requirement, we would also like to mention about the out of scopes or the assumptions what we are making, which we do not want to focus as part of onboarding of the users. So we will assume that the users are already logged in into our system, the third-party payment gateways integrations, and how these movies are being added or removed into the theater. Probably we will touch upon this when we will discuss about the deep dive. You can make a note of here like your assumptions or out of the scope requirement. For saving the time, you can also discuss orally instead of spending your time on making a note of all those things, because these are the assumptions which interviewer are also not expecting you to elaborate. In step 2, when we are discussing about the non-functional requirement, we wanted to first start with the low latency of the system, which we wanted to propose for the search of the movie. What does that mean is we should have a specific SLA. When user types a word in the search bar, user should be able to see the list of all the movies belonging to that criteria within, let's say, 1 second or within 500 millisecond. So these are the qualities of the system which we wanted, and how do we solve this problem technically, that we wanted to discuss further. At this point of time, we are just making a note of it that we need this specific quality into the system. If we talk about the cap theorem here, we should specifically mention if we partition the data at this point of time we don't know whether we need to partition the data or not, but some kind of a intuition we wanted to give, that we are thinking a back of our mind about if we need to partition the data, we wanted to give the priority to consistency over availability. But instead of just throwing these jargons, we wanted to mention which specific use case where we wanted to prioritize consistency over availability. We must have the consistency on booking tickets. What does that mean is, if a user is trying to book a ticket, it's okay to have some delay, but we should have the consistency in the system for ticket booking. We do not want to prioritize the availability in this use case. That means that, let's say if customer is trying to book a ticket, we book it very quickly, and asynchronously in parallel we are trying to save into our database. But meanwhile, we send the confirmation to the user that your ticket is booked. Still, the record is not being created into the database. So this would be pretty fast, and we can update the records, database records into the system parallelly. But this is what we do not want, because ticket booking is something which user is looking at that point of time about the confirmation on the ticket. Let's say if the ticket is not booked, user can go and try booking other tickets or other movies into other theaters. So it's okay to have some delay here, but we need a consistency on booking. In the second use case for CAP theorem, where we wanted to prioritize availability over consistency, in this case we wanted to prioritize for searching movies. What does this mean is, when user is trying to search for a movie, after entering few keywords, user wanted to see the movie list of movies as fast as possible. It's okay if some admins are trying to add the movies in the backend parallelly, and that information is not available within that millisecond of time. So let's say at that specific time there are 10 movies exist in the database, and if user enters few keyword, those all 10 movies matches the criteria, but still users see the 9 movies in the list. User doesn't see the 10th movie in the list, because that point of time movies are being added into the database, and how this movie will be available to the user, there might be a multiple phases in between, and that's where we wanted to prioritize availability over consistency. Here you can understand, instead of just discussing about the CAP theorem in a generic term, we are discussing about the CAP theorem for these specific use cases. And in fact, these are the very key pointers which you should highlight in the interview to show your in-depth technical skills. And this is how you will be moving towards the scalable system, on making the choices of the databases which you would be required, or the caching which you will require. Also, you can discuss about the back of the envelope calculation. I would suggest you to get this clarified with the interviewer if he is looking for you to get the actual numbers here for the users who are using your system. For learning purpose, I am going through this step, but in actual real interview, I would suggest not to get into this in detail to spend much of your time. So let's start with 100 million daily active users we have, on which every user is searching for 10 times in a day. That will be equals to 100 into 10 to the power 6, which is 1 million, into 10. This is equals to 10 to the power 6, 7, 8, 9, and we do have approximately 10 to the power 5 seconds in a day, that is, which is equals to 10k. So now you can see we do have 10k requests per second for search. Next, for ticket booking, we have 100 million users, and let's say 1% of it, which is 1 million user, are trying to book the tickets every day. We have these many seconds in a day, so which would be 10 to the power 6 divided by 10 to the power 5. That would be your 10 request per second you are getting for ticket booking. And if you need to consider the peak traffic, generally this when the movie is launched, and when the festival season, when the airlines has opened their ticket bookings, so generally in this kind of system the peak is very important. And probably if you consider the peak as 100 times peak here, then it would be something like 1,001k request per second you are getting for the ticket booking. These are the calculations for the search request and the booking request. And as you see by now, this hardly mean anything for this system design interview. You get the numbers for the search and for the ticket booking. You know from this is you need a distributed system, because a one server will not be able to book these many tickets in case of concurrency. And here if you, let's say, some having some SLAs of 500 millisecond, and if you are having a single node for serving these many requests per second, you might not be able to meet the SLA of 500 millisecond. That's why you would need multiple instances of this service or API for the search API and the booking API as well. So again, I have just mentioned here these details for your learning purpose, and if your interviewer is actually looking for you to get into these calculations. Similarly, for storage, how much storage do you need? So you are having 1 million tickets being booked every day, because of 100 million, 1% of the users, let's say, trying to book a ticket. So 1 million, and let's say each ticket size is 1 kilobyte, which would be 10 to the power 3 with a very high level numbers. So you will need to the power 9, which is 1 GB of data per day. If you are considering for year, again we have 365 days in a year. We generally take 400 days in a year for our easy calculations. And let's say if you're considering this for the next 10 years, so this into 1 GB of data, which is 10 to the power 9, this will be equivalent to 10 to the power 9, 10, 11, 12. 10 to the power 12 is the terabyte, and we have 4. So we need 4 terabyte of data to store the storage for tickets for 100 million or 1 million people are trying to book tickets every day for the next 10 years. So if you would see here, the data is also not very large. This is 4 terabyte that can easily fit into a single server. So do you really need to partition your data? Now you can think about the cap theorem, which we have discussed earlier. So as I have mentioned in my previous video, when you need to partition the data, there are two reasons. One is the data cannot fit into a single machine, or the number of requests are very high. So let's say if you are storing a 4 terabyte of data in one server and you get a search request or a booking request, you need to do the complete scan of these tables. Let's say you are scanning 1 terabyte of data in your table, in your search table or a booking table or getting a movie detail table. That's gonna take huge amount of time. So for this reason, probably you would require to partition the data, to split the data into a server which might have, like, let's say 10 GB of data. So instead of scanning a terabyte of data, you will be scanning in few gigabyte of data, and your performance would be much faster. So this is about the non-functional requirement, and I would suggest and highly recommend to not to get into these details. Just randomly suggest some numbers and get the buy-in from the interviewer that you are looking for the partitioning of the data that you will want to explain and get into detail when you discuss about the deep dive of the system, and that you have mentioned here with a very quick information that you are thinking about the cap while searching for a movie or while booking for a movie ticket.